All right, ladies and gents, we are doing lesson 15. And on lesson 15, we are still looking at comparing the size of units by thinking about them or drawing models. So we're going to do just a few together to practice, so make sure you have your red notebook, and if you don't, get it now. All right, we're going to go ahead and compare 1/3 with 1/5. Please write that down. Now, you could certainly use any way to figure this out. I always write mine out in fraction form first, so that way you can compare them. I have 1/3 versus 1/5. Well, this is 1 out of 3 equal pieces, and this is 1 out of 5 equal pieces. So if you want to draw your models, remember your tape model or area model have to be the same size. So if I'm dealing with thirds, I'm going to cut this into thirds. If I'm dealing with fifths, I'm going to cut it into fifths. And I'm going to shade in 1/3 versus 1/5. You probably already realized that 1/3, my piece is bigger than 1/5, so I eat the larger piece. Make sure you have all of this in your notebook. All right, let's go ahead and move on. This time we're going to look at some other types of fractions, like 3/5 versus 6/12. You can use a couple of different reasonings through this. You can use benchmarks if you'd like. So remember, our benchmarks are the whole before and the whole after plus the halfway point. Since these are neither above a whole, our benchmarks would be 0, 1/2, and a whole. If you haven't written this yet, you need to get it down. All right, so my benchmarks, I can look at 3/5, and I know that half of 5 is 2.5. And I know that half of 12, is 6. So this would actually be equal to 1/2. However, this is 3, which is more than 2.5. So that means that 3/5 is more than 1/2. Therefore, it is bigger. That's how I rationalize that. You could have modeled it. Just make sure your models are big enough so that you can cut this one into fifths and you can cut this one into 12ths. Go ahead and pause while you cut this particular model into fifths and this one into 12ths. Go ahead and pause. All right, what you should have come up with is you should have come up with fifths and try to make them as accurate as possible. And then 12ths, you should have written 11 lines. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. As close as I can get them. I shade in 3/5 and I shade in 6/12. 1, 2, 3, 4, 5, 6. Obviously, my 3/5 is bigger than 6/12. So I was correct. All right, let's go ahead and do one more. This one that we're going to do is going to be larger than a whole. So let's do 5/4 versus 6/2. My recommendation to you is always pull out the whole. When you see that you're dealing with a numerator larger than a denominator, you want to create what the whole would be. Make me a mixed number. So here's what it should look like. Pull out the whole, 4/4. What's left? Hopefully you said 1/4. I put that into a mixed number. 4/4 is a whole. And I bring over my fraction. If you don't have all of this, you need to get it because we're doing this together. And I'm pausing so you can get it down. 6/2, if you pull out a whole, that's 2/2. But I'm not at 6 yet. Pull out another whole, that's 2/2. But I'm not at 6 yet. Pull out another whole, that's 2/2. Guess what? 2, 4, 6, I'm there. How many wholes is that? Well, it's 1 plus 1 plus 1. I'll make these arrows. So that equals a total of 3. So obviously, which one is bigger? 1 1/4 or 3? Well, if I have 3 pizzas, or I have 1 1/4 pizzas, well, the one that I would want to serve my friends would be 3, so we could have more pieces. That is one way to do it. The other way could have been to actually draw the model. So here's my hole. I cut it into fourths. Make sure you stay with me. Mark it as a hole. As I pulled out 4/4, so I shade them in. Then I had 1/4 left. So I made 5/4. Or, again, keep your hole. Has to match up. See how it's the same size about as the other one, as close as I can get it. Turn this one into halves. Oh, that's one hole. But I have 6 halves. That's only 2 halves. Zoop. 4 halves. 4 halves. Zoop. 5 halves. 6 halves. So 1, 2, 3, 4, 5, 6 halves. Obviously, this one right here is larger because he took up a lot more space. But remember, they're the same size to start. All right, one more, and we will be ready to roll. I'm going to actually show you a different method on how to make this, figure out which one's bigger. I'm actually going to use one from today's lesson, or from today's problem set. We're going to do 3/4 compared to 7/12. So you know you can't compare them because you don't have the same denominator. So I'm going to show you how to get the same denominator. So I always take my multiples starting at 4 and count up. 4, 8, 12, 16, 20, 24. And I'm going to stop right there. And I'm going to see if I can find any matches with the multiples of 12. Now I'm going to do the multiples of 12. So start with 12, 24, 36, 48, and let's stop right there. So these here are the multiples of 4, because 4 was my denominator. These are the multiples of 12, because 12 was my denominator. Do you see anything they have in common? Well, hopefully you said, oh, look, there's a 12 here and there's a 12 here. So since they both have 12 as a common denominator, you can turn them both into 12ths. So the best part about this is these are both 12, so guess what? These will both be 7s. So that doesn't change. This one does, however. How do I get from 4 to 12? Count by 4s. 4, 8, 12. Oh, I multiplied by 3. What you do to the bottom, you have to do to the top. 3 times 3 is 9. So you can ask yourself, which is bigger, 9/12 or 7/12? We could have also just as easily drawn a model or used our benchmark fractions. Since they're both below 1, they would have been 0, 1/2, and 1. You have a few options. If you didn't understand this method, keep playing and I'll do one more. If you did understand it, you can stop now and go find a partner to do the rest of 14, 15 with on the new page. All right, good luck. If you're staying with me, I'm going to clear the screen and we're going to get moving. All right, if you stayed with me, here's what we're going to do. We're going to actually compare 7/10 to 3/5. 7/10 to 3/5. So I count by multiples first. 10, 20, 30, 40. So those are the multiples of 10 I'm going to put out. Now let's do the multiples of 5. 5, 10, 15, 20. Now this should all be written down. Don't forget. Now you'll notice, hopefully, what these two have in common as far as multiples go is they have a 10 in common and they have a 20 in common, just based off of the ones that I wrote out. I could have written more for 5 and 10, but I just stopped there. So I can take the 10 and the 5 both to 20, or 10 is already a 10. Let's leave it. And then just move our 5 to a 10. So this guy's going to go to a 10. He stays the same. Because the 10 stay the same on the bottom, the 7 will stay the same on top. My 5, however, is going to go to a 10, or tenths, so I have to change some things. My 5 times what gives me 10? We'll count by 5s. 5, 10. Oh, it's times 2. Which you do the bottom, you do to the top. 3 times 2 is 6. So which one is bigger, 7 tenths or 6 tenths? Well, hopefully you said 7 tenths. Because 7 is bigger than 6. All right, please go find a partner to work on 14-15.